Did you know that spider silk is proportionally stronger than steel? And that some spiders can produce up to 7 different types of silk? Spiders are true engineers of nature, and their webs are not only used to catch prey. Stay with me to discover the fascinating secrets behind these complex and ingenious structures, and understand why these tiny architects weave such extraordinary webs. To understand why spiders weave webs, we must first look at how they do it. How do these tiny creatures manage to make such strong and precise webs? The answer lies in their spinnerets, specialized glands that produce silk. This silk, although thin and light, is proportionally stronger than steel. Each spider has several types of glands capable of producing silks with different properties. Some glands create an extremely sticky silk to trap prey, while others produce a non-sticky silk that allows the spider to move on its web without getting trapped itself. Each thread, each strand of silk has a specific role in the web, like the different pieces of a puzzle. Spider silk starts as a liquid inside their glands. It is expelled through structures called spinnerets, located at the back of their abdomen. In the blink of an eye, when this silk comes into contact with the air, it solidifies and becomes a thread. This thread can be modified at will, thicker or thinner, more or less elastic, depending on the spider's needs. Scientists have long sought to understand how such a fine silk could be so strong. The answer lies in its unique molecular structure. Today, researchers are working to artificially reproduce this silk for use in fields as varied as medicine and construction. So, why do spiders weave webs? The first and most obvious answer is hunting. Webs are primarily used to capture prey. These invisible but formidably effective traps allow spiders to immobilize their prey without having to actively hunt them, an essential energy saving for these small creatures. When flying or crawling insects cross the web, they find themselves trapped in the sticky threads. The spider can then wrap them in silk to preserve them and eat them later, a bit like a pantry for lean days. But the web is not only used for hunting. Spiders are masters of ingenuity, and they use silk for many other functions. For example, some species build silk shelters to protect themselves or their eggs. These silk cocoons ensure the safety of future generations of spiders. Silk also plays a crucial role in their movement. Some spiders weave a safety line when they move, a bit like a climber securing themselves with a rope. If they fall or slip, they can quickly climb back up this thread to regain their original position. It's like a built-in safety belt. Another fascinating aspect is communication. Some spiders use their webs to talk to other spiders. The webs vibrate at the slightest movement, whether it's prey or a rival. These vibrations travel along the threads and allow the spider to detect precisely what is happening on its web. It's like a natural communication network. Some species even use more vibrant silk patterns to attract the attention of a potential mate, while others use these vibrations to ward off intruders. The web then becomes much more than just an insect trap. Not all webs are created equal. Each species of spider has its own design preferences, and these choices are never left to chance. Take, for example, the wasp spider, which weaves magnificent spiral webs. These structures are ideal for catching flying insects, with a strategic arrangement of sticky threads that maximize the chances of capture. Others, like wolf spiders, build underground webs in the form of tunnels. These webs are perfect for trapping insects that move on the ground. They are true works of biological ingenuity, each adapted to the environment and hunting habits of the species. The silk itself is incredibly versatile. It is not only very strong, but also very elastic, able to absorb huge shocks without breaking. Imagine a web that remains intact even after catching an insect in mid-flight. This elasticity allows the web to maintain its shape and effectiveness, even after several uses. The unique properties of spider silk have fascinated scientists to the point that they are now trying to reproduce it for industrial applications. From ultra-resistant clothing to medical materials, the possibilities are almost endless. Spider webs are fascinating in many ways, but they also hold some fun secrets. Did you know that some spiders eat their own webs? This allows them to recycle the silk and recover valuable nutrients. They can then weave a new web without having to expend more energy. And that's not all. There are aquatic spiders, such as the diving bell spider, which weave webs underwater. They trap air bubbles in their webs to breathe underwater, a bit like natural scuba divers. Another impressive fact: a spider web as big as a football field would weigh barely a few grams. That's how light and strong silk is. In short, spiders weave webs primarily to catch prey, but also to protect themselves, communicate, and even move around. These complex and resistant structures are the result of millions of years of evolution. Their ingenuity continues to fascinate scientists. And perhaps the next technological revolution will come directly from these small creatures. The next time you see a spider web, take a moment to admire this true work of natural art. They are much more than just traps, they are miracles of biological engineering. So what did you think of this exploration of the fascinating world of spiders and their webs? Did you learn anything new? Share your thoughts in the comments and don't forget to subscribe to discover other wonders of the world around us.